Alright, so this is like my 10th time trying to do this, and the audio's just been so bad every time I decided to turn my heater off. So I'm a little bothered that this is the 10th time, and also it's cold as hell in here now, so forgive me if this is rushed. But this is the turn-based RPG combat system. This is the next practice session we're going to be doing, with a focus on the system part, meaning that the art will probably be really bad because I don't care about it. Here's an example of what I'm talking about, is my programmer art. But one of the benefits of drawing out what your interface should look like first is you can kind of pick apart what needs to be done. Okay, I need health bars or some indicators, some stats, stuff like that. I need one for each of them. I need 2 characters at least. I need this narrator box, and then I need a menu thing like that. So the thing that I was thinking about as I was designing this is perhaps this part is left to the implementer, and I just need to know, all right, what of these things did you select? Send me a code and I will process it. So I probably don't even need to account for that in this part, the system part. So without further ado, what are the objectives of this practice session? What are we practicing? Designing and developing systems. I'm not really interested in much else. When I say designing, I kind of went a little overboard, and we'll talk about that in a second. So pre-session, I have actually already started this, unfortunately. The first recording I did of it was so bad with the audio that I just threw it all out. So I'm kind of going to jump around and like probably ADR over the old footage, so forgive that. But here are the systems I'm going to try. I'm going to do a turn and a round system. We're going to have actions and items and stats and gear. I don't know if an item is the same as an action. We're going to come back to that in a second, though. So how do other people do it? There's certainly not an infinite number of things in our game. There's not an unknown number of things in our game. They all know. For example, for the number of skills a character can have, Persona will have like, I think 10. I don't know if it's 10 or 8. Pokemon, you have 4. Octopath had 8. Final Fantasy, I never played it, so I don't know how many they have. But World of Warcraft, you get a big spell book, but that's a finite number. So in our game, a character can have 4 abilities, and they all come from their gear, plus attack and defend. So we have 6. Sorted. Stats. I didn't want to just borrow the Dungeons and Dragons stat set because it's boring. We all know that one. So I made my own. The stat set is called Babes. It's brain, agility, brawn, energy, and soul. And then the defenses are calculated from those. So in total, we have 8. I have a proposal I want to implement. If a stat reaches 0, any stat reaches 0, that's how you die. How many turns can each character take? I'm going to say 2 maximum. So most of them will start at 1 and then eventually they'll get to 2. So that means we have to have a maximum number of turns of however many characters there are times 2. Now, since I started this already, I have determined that I want 8, so it can be 4v4. So that means 2 max per round times 8. There we go. The biggest the biggest round that we can have is 8 rounds, or 8 turns. Gear. The gist is I want 1 of every type, so cloth, leather, whatever. And past level 1, they'll start having stat benefits. I'm going to talk about this a little more in a minute. We'll get to that soon. So here's the implementation plan that I had. We have stats. They're going to have a current value, a max value, and a buffed amount. And then we're going to need an enum to index into it. I said AOS. I meant SOA. We're going to come back to that again in a minute. So our struct is going to be assigned short for what our current value is. It might even be able to be unsigned. Yeah, I think that can be unsigned. I made a mistake there. This is our max. So current value can never be greater than max. The way that you go above your max is through buffs. So if your buffed value plus your current value can go over that. But they're all signed. These are signed. Or buffed is signed, so you can actually have a negative number in here. So you would be plus -2, which is the same as -2. So that can actually put you below 0. So that's how you would be considered dead. Abilities are functions. They're going to have a caller and a target, and it's basically just going to be a huge array with all of your possible abilities. The caster stores a list of these indexes to the ones that they can use. A function will check with the caller and determine what it needs to. So like, what's your strength stat or your bronze stat? All right, we're going to attack against this guy's other stat. So here's the general idea. We're going to have a function pointer callback style thing up here, where it's going to be called do ability func. It's going to take 2 parameters, an unsigned char caller, unsigned char target, because that's as small as I can get, because we only have 8 each. Here we have some function defined somewhere, and it's going to be whatever we call it, ability equipped weapon attack melee, big long ugly name. And then we're going to have the 2 target and caller thing. And then for our manager, we're going to do ability func ability list, max abilities. I think I said 32, but we'll probably be changing that. And then it's just going to be a list of all of them. And then that's how you're going to call into it. Items. So other than like gray loot, stuff that's specifically there for you to sell to make money, what do we do with consumables? So this is what I was talking about. Are items just abilities that cost inventory instead of like mana, or are they different altogether? So maybe we'll have a wrapper function that wraps the ability and subtracts it from your inventory. Ailments, not specifically ailments. I probably should have called it something else, but we're going to have buffs and debuffs. Same as an ability, all of the buffs and debuffs are going to be stored in a big array. And lingering effects like poison, burn, maybe even like bonus to armor or bonus to health or something. That could just be an enum of masks. So I've done that right here. As you can see, I'm using bit fields again because I hate being told no. We're going to explore this at the very end, but this is basically the size of one integer. So the size of one int will hold all of our stats, and since it is a signed stat, we're going to have 4 bits, so the last one is a signed bit, which means we have plus or minus 7 to work with. Our elements will be just a big old list of, so this next one will be a 1 here, and we're going to XOR against this for resistances. So if we want to apply something, and if they already have the resistance, we're going to XOR against it, and it's going to say, oh, sorry, he's already set, I can't set that. Gear. What we're going to do is slots, buffs, resistances, which is what I just talked about, and abilities. So gear can give you an ability such as like shoot arrows and stuff, or like spells maybe. Your slot is just slot's going to be interesting. We're going to come back to that in a second. So we'll need 2 functions to access gear. We're going to need equip and unequip to attach the gear and the benefits to the user of this gear. We're coming back to gear because there's a lot of interesting things to say about it. So here's what a gear looks like. I did make a typo here. I should have moved this char next to this char down here and put the short up top, so then it would be of size 4 bytes. Instead, right now I think it's 6 because there's padding after this one and after this one. So I'm not going to do classes or specs or anything like that. Everyone is just custom peasant thing. You all start with low stats and then you level up and put your gear on to get your stats higher. Character sheets. So I started to make a character sheet where I was like, oh, here's a list of all of the indexes into the gear table that I have. And then I thought about it and I was like, wait a minute. How much gear do we have? So I made like a very quick little combinator to see how many types of gear might be in the game. And this list is not final because, like I said, level 1 gear is probably not going to have any stats to it, so we can get rid of all of the things that don't say default for level 1. So this list might be smaller. This is just a general concept, but if I can get that down to less than 255, we can encode it in 1 byte. And I know what you're thinking, hey, what are we encoding it for? Don't we need to know like what we're wearing? I thought that first approach was pretty good. Think about it. We need to equip and unequip our armor. Wearing it is cosmetic, right? So when we equip in our armor, we're going to add all of the benefits to the user, like I said. So if we can encode all of the armor types, even in a short, even if I have to do that, the character only ever needs to know if they are wearing something, and by the rules of our system, if they are, it is assumed that they equipped it, and if they are not, it is assumed that they unequipped it. So instead of 7 chars, we can make 1 char and use 7 bits as flags. Put a pin in this. I am sabotaging myself right here, but doing it on purpose. I'm aware of what's going on. So yeah, character looks like this now, and if we're just storing one char in a struct, we might as well just store the char. So turns and rounds. despite being the simplest of all of this, it's just a regular old queue, sort of. We need to wait till the character is defined. Otherwise, we're just going to make a queue of numbers, which, spoiler alert, we did that anyway. So yeah, a round is just a queue of turns. And a turn is going to have a turn taker, a character, and a step in turn. Now, a turn taker is going to be something like what player is acting, like stepping back away from the thing. Who's acting? Is it the AI? Is it the player 1? Is it player 2 if this is multiplayer? Who do we give control to? Character, self-explanatory. And step in turn, just in case, think about how in some card games you have like, I need to draw first, and then I need to play, and then I need to discard. Otherwise, the rules will break down. That's what I'm talking about when I say step in turn. Dying. When a character dies, their number is just removed from the turn queue. Nothing else happens. You skip their turn. This is why I said it's kind of like a queue, because it's not really like a queue. We're not popping or queuing and in-queuing and de-queuing and stuff like that. It's a little different, but we are doing first in, first out. But it's not really out. It's just pass. So the reason I'm doing it this way is resurrection magic or items will just put your number back into the queue. So why would you take it out of the queue? Well, instead of iterating through the whole queue and checking if someone is alive, we just assume that everybody in the queue is alive, and anybody who's dead, we just move them off. Great. So win and lose. How do you win and lose? I don't have to explain this to you. I'm putting in here for the specification just to make sure that this is complete. So I'm pretty sure that's all of our implementation stuff. So let's talk about some stuff. This is structures of arrays versus arrays of structs. Everyone who does data-oriented design style videos will talk about this, so I'm kind of going to breeze through it. Here's what I was about to do. I was about to make, I guess, a struct of all of these different components that make up a character, and instead what I'm going to do is I'm going to make an array for each type of component, and then your character is just an ID, and then if I go to 2, I go through 2 on all of these. It makes more sense in practice, especially when someone else describes it, but so why is that better? So each pass through the game loop, we don't waste as much. If you give a struct every time you loop through something and you don't use it, you're wasting all the stuff that you use. Let's say one of the system things I'm doing only wants to know what your sheet looks like. All of this other stuff was passed in, and it's just not being used. It's wasted. With this, we can design a system that says, I would like abilities and buffs, please, and then I will only be operating on those. So one last thing before I start. I was talking about bit fields in the Minesweeper video, and I want to go back to them. This is the same article from last time. Bit fields, they sound great. They sound really cool, and I would love to use them, but apparently they're scary. And when I was looking around on like Stack Overflow and stuff as to why you shouldn't use them, people were just kind of saying, don't ever use them. And I didn't really see anybody saying why, and that kind of pisses me off because it's like, it becomes religious at that point. I don't know. So what I did was I went into my dev environment and I found out what I'm using. I'm using GCC 13.1. I went to Godbolt and plugged in GCC 13.1, and then I tried it. What happens? So I'm not the best at assembly, but here's my general understanding. This stuff right here, where it's Q pointer, this pointer stuff is this right here. So we don't have to worry about that too much. That's why we have a quad word. But if we look right about here, that's what this is. And then this, move from our pointer into this. Move from the pointer into RAX, and then we're going to move the thing in RAX into EDX and EDX. I don't know why they mask it at -8. I'm still trying to figure that part out, but that lines up with this. And then this right here is this bit right there. So as far as I can tell, this behaves exactly how I expected it to. So let's try that thing that they did where they just popped it right onto the end right here. Just have this one bit right there. So I set that up, and all the stuff highlighted in red over here is kind of also doing exactly what I expected it to do. The guys who work on Linux are much smarter than I am, but I don't really see what their issue was. Well, not inherently. I think what the issue was, in the comment section kind of pointed this out, They have a 16-byte aligned struct, and then they're trying to add 1 bit after whatever lock was. So I think lock might have been 32, and then this 1 bit was 1, and that's why it was doing that. But again, I don't know. TLDR, I'm just going to be careful, and if anything weird starts to happen, it's probably because of the bit fields, and I'm just ready to deal with that. So I've already started, but for the sake of the video, let's get started.